Very quickly, we begin today's lesson. Today we have a very intense lesson to do, very quick and fast. And there will be, after that, your turn to go home and do your due diligence again. But before we begin, something happened yesterday, and I was quite ruthless in doing this. You can see me doing this, and then there's this worksheet, and then there's pizza. So there's some writing on this, and then there's the pizza set. First, you will actually you can come and take the sheet. So there's this pizza copy, and then there's the triangle worksheet as well. Yeah, that's true. Okay, so what happened is that yesterday, I'm going to share see. I recorded it and so you can see that in this video, how now, so I was demonstrating yesterday that you can piece the pizza slices onto the triangle, and that's what we did during maths outdoor lesson yesterday. So we took the pizza slices, Ethan. I just gave the worksheet to you. So we did this activity in the outdoors, and we tried to take the angles to compare that onto the triangles. And then during subclass, we will identify and measuring all the different measurements of the triangle on the worksheet. So we measure and we write down the different properties. So Ethan, you have missed out on this. Can you go back and catch it up on your phone? All right, so we wrote down and find out the information. And towards the end of the lesson, after we learned about the different kind of triangles, I have not done the last one, but the first one we know that it was the triangle triangle. The second one was a equilateral triangle. 6 centimeter. Yeah, so this was we figure out that this was a equilateral triangle. Then the last thing I showed you, do you remember what I showed you the last thing? And it was like quite impactful. Everybody's like, wow, something happened to the triangle here. So yeah, so I cut the triangle up in a way. So I'm gonna stop here. So what I did was, ask you to go back and try it out. So there are a few things we are trying to learn and figure out. So yesterday, what I did was I tore out this triangle on here, this triangle, and I cut out this triangle. The last triangle I have not talked about it yet. There's a special name to it as well. So for this triangle, this is a right angle isosceles triangle. And then for the last triangle, if you put your measurements now, let's do the one right in the middle, okay? And let's figure out what is the name of this triangle. Can you take a ruler? Anybody needs to borrow a ruler to do? And protractor? By now, everybody should have a protractor, right? If not, the pizza slices will be due. You have what? Oh, come on, take. This is the triangle. This is the pizza. Huh? I'm not muted. I'm muted. Okay. Anybody need a plural protractor. You can have it type of magnetic. And I told you to like cut the triangles right? No, sorry, cut the pizza. I didn't say cut the triangle. But actually, I printed enough extra triangles that you can play with. So please use your ruler, measure all the measurements of these triangles here. Okay, so have you measured everything? So I'm looking at the one in the middle here, the big one, and I use my long ruler to measure. You'll find that this long side here is 20, 24 centimeter. And then this side is 20 centimeter. Are you sure? It's 27. You mean this one? Oh yeah, you're correct. So this side is 20 centimeter. And then this one is 27 centimeter. And then on here, for this one is about 8 centimeter. And then this side of this triangle is 7.2, about 7 centimeter, 7.2. And this side is about 5.7. And you realize that for this triangle, this is the green color triangle, right? Sorry, not the green color triangle, the orange triangle. This one is the orange triangle, and then this one was the green triangle, the equilateral triangle. Okay, and then this one, the first one is the right angle triangle. So you have the right angle triangle, and then yesterday the discovery was that this right angle triangle happens to be isosceles as well, because there are two corner angles that are the same size and two sides of a triangle equal. And then yesterday we also managed to draw some of the triangles that are right angle but not isosceles. Right angle but not isosceles. And then, but in the attempt to draw triangles, I realized that some of us are like, I can't draw. I hear a lot of people saying, it's so difficult to draw, how to draw, very difficult. Right? So I went back and then come up with more ideas and tools to help us to be able to manage drawing angles, triangles and angles better. So a lot of work and effort I put in to help us to deal with the next learning objective. There is learning how to draw triangles from scratch. Now, so from the first two triangles, you realize that there are some special names. Right angle triangle, isosceles triangle, equilateral triangle. Then this triangle, Is that a right angle? Don't have. What angle is this? What size? What size exactly? You took your pizza slice and put on it. What size of it? I can use my protractor on this one as well. This one is 75. Okay, then this one here. This one is 45 degrees. And this one is 60 degrees. Okay? This is 75 degree, 45 degree, this is 60 degree. And then for this one, this is 60 degree, 60 degrees, 60 degrees. Then the right angle triangle, this is 90 degree, this is 45 degree, and this is also 45 degree. So we figure out, this one, all angles are different. Then it does not have a right angle. It's not a right angle triangle. It doesn't have two angles that are at the same size. All sides are different measurement. So this triangle doesn't have the it doesn't have a special name called triangle, it doesn't have a special name called isosceles, it doesn't have a special name called equilateral, but it still have a special name. What is the special name? It's in your textbook. Christabel already knows. Anybody else knows it? Okay, there's a special name for these triangles. Acute triangle, that's correct. So this is an acute triangle. Okay, then what about an obtuse triangle? That's a very good question. Can you find that out in your textbook? I don't want to cut my triangle. Look, look. I do not want to cut my triangles, but I want to still prove that sum of angles on a triangle adds up to 180 degrees. Now, instead of like tearing it, look, I find a straight side of the triangle. Are you looking? So you say you don't want to tear, right? You know, like so brutal tear, you know the one. So I take a straight side of the triangle. I take one corner. I try to put it on the straight line. And then I try to make this corner also meet at the straight line. Can you see how I fit? Okay, need to be more accurate. Can you see the straight line here? Open, close, open, close. So this was 60, 60, 60. Which you can see that is in your textbook as well. It's shared in your textbook as well. The textbook is showing you how you can actually hold it up and you see the 180 degrees as well. So you realize that this works for any kind of triangle. That's why the property of sum of angles in a triangle will always add up to 180 degrees, no matter what kind of triangle it is. Can you understand it? Now, so just now we also mentioned about obtuse triangle. Can you see? This is on page 125 of the textbook. Knowing with what we have learned just now, this green triangle, what kind of triangle is it? Acute and measure is an equilateral triangle. The second one here, isosceles triangle. This one, look at me. Obtuse angle triangle, that's correct. And written here, obtuse angle triangle. Why is it obtuse angle triangle? Yes, so X and Y are acute. Which one is obtuse? Yes, that's correct. So you can see in the previous pages also, the examples of triangles. Over here on point 5, these are the obtuse triangles. Because one of the angles in the triangle is obtuse. Now, is it possible that all angles are obtuse in the triangle? Good that you try. Okay. Now, I realized that I give you time to explore this property of angles in the triangle. There isn't time to move on to my next task. But I'll try to run you how it is like in a arrange of different. Can you look at your textbook now and can you mark out this page as homework? Page 116. You already did? Okay, circle the page now and try out as homework. I have one more page. Can you write it down in your notebook then? 160. Okay, look at it. Try this out as homework. 116. Okay, That's 116, and I want you to read up the drawing triangles part. That's on page 120. Because tomorrow we are going to challenge drawing triangles. Yes. 116 and 120. Is that okay? Not a lot of homework. I'm arranging right now. Okay, bonus. If you feel brave enough, you can try out the drawing on this page. Page 123. Okay? Then I'll give a prize to anyone who give it a try. Draw out the triangle on page 123 according to the properties that is stated. Okay, from have you written it down? 116 and 120 and 123. You do 123, you get a prize. Yes. 116, 120, and 123. I'll collect that tomorrow. I repeat one time, huh? 116, 120, and 123. You do 123, you get a prize. Okay? Okay, finally, just to let you know what is the plan for tomorrow. Okay, so tomorrow, right, we are going to go like trying to draw out triangles, and I really prepared my activity sheets. Okay, we need to practice on how to draw triangles. And you see that we really need a protractor. Okay, it's not my fancy transparency. This one can only help you to measure. It cannot help you to draw. You need a proper protractor to draw. Okay? Huh? You can cut this. But it's not, I will not say if there is trustworthy in the exam time. Because it's still a very soft plastic. It's not a firm, solid plastic protractor. So this is our task for tomorrow. If we do this worksheet well, that means we can miss out the relevant verbal pitch. Okay? Okay, that's it for today. Anybody got any questions regarding homework? I should bring up my prizes for our friends who bid. Okay, I'll end here first.